Okay, welcome to question number 2. So for here, it's going to be a graph question. So looking at it, says the amount of water in a storage tank in gallons is modeled by the continuous function on the time interval, yada, yada, yada. It's given as follows. Rate which water enters the tank, given here. Rate at which water leaves the tank is given here. So looking at this really quickly, I'm given two different things, and I'm going to highlight it. Red is how much is leaving, whereas this curve here, this is how much is entering. Okay, so remembering that off the top of my head, this is telling me how much is leaving, how much is entering. Next, it says that f of t is the rate at which water enters. So then don't forget, this is your rate. So if I'm saying how much, if I'm looking at y in the context of this, f of t is going to see how much water is coming in. Okay, and then f prime of t is going to tell me how much the rate of water is changing, and f of t is going to be telling me how much water there is. Okay, so again, we're making sure we know what each of the different parts are. It's good to kind of have this in the back of your mind. Again, I'm just thinking of this as we're going in. And then it says this, the graphs intersect at t equals 1.617. So I'm going to just mark that out over here, 1.617. And then 5.076. All right. So that's what we have here. At the time, the amount of water in the tank. So what we know is that the amount of water at the start is 5,000. Okay. So number one, it says how many gallons of water entered the tank during this interval. Round your number to the nearest gallon. So again, what we're saying is we're given f of x or f of t. And if f of t is going to be the amount of water that is coming in, so at t equals 1, f of 1 is going to be saying this is the rate at which water is coming in. So it's going to be something like 10 gallons per minute or something like that. In order to find how much water came in total, we integrate it. And then we say this is how much water came in at this minute. And if we go previously, how much came at the minute before, and previously the minute before, so on and so forth. So when I'm going to integrate, I'm going to say integral from 0 to 7 of f of t dt. And what this is going to do is this is going to tell me this is the amount of water that came in for every second at hour 0.1, 0.2, 0.3, so on and so forth. Now, if I'm going to do this, this tells me how much water came in during that time, how many gallons of water entered the tank. So that's what we're going to be looking for. So again, I'm going to be plugging this into my calculator. So f of t is given as 100t squared sine square root of t. So I'm going to be plugging that into my calculator, and then I'll be right back. So once I plugged it in, I got 8264 gallons. And again, it does say to round your answer to the nearest gallon. Please be careful of that. Make sure that you are doing that rounding. All right. So next, what we're going to do is going to say find the time interval during which the water in the tank is decreasing. Now, basically, if we interpret that, we look at the graph, we're saying, when is it that the amount leaving is more than the amount entering? And if I look at this, basically what's going on is my leaving is more than my entering here. So wherever my red lines are above my blue lines, that's where it is. So it's going to be, I'm this purple section here, and on this purple section here. These are the places where I have more water leaving than water entering. So what B is asking me is which the water in the tank is decreasing. What that means is in terms of entering and leaving, I have more water leaving than there is entering. So basically for B, what I'm going to say is on the intervals, 0 is less than or equal to x, which is less than 1.617, and 3 is less than, or was it 3? I'm sorry, what was it? Sorry, not 3. Yeah, 3 is less than x, which is less than 5.076. Okay? And again, the reason why is I'm saying from here, which was given as 3, when it switched all the way to here. Water is decreasing. Because more water is leaving than entering. Okay, so again, with these graph problems, a lot of it is just interpretation. Do you understand what the question is asking, what the equations represent, and all of that kind of fun stuff. So we're done with 2 out of 3 questions, which means the third one is going to be a bit of a doozy. It says, at what amount of time is the water in the tank the greatest? To the nearest gallon, compute the amount of water at this time. Okay, so basically what it's saying is, at what time is the amount of water in the tank the greatest? So if I'm looking at that, what I want to see is, when is capital F of t the largest? Okay, so I'm talking about max mins. And when I'm talking about max mins, I'm saying, when is my derivative going to be equal to 0? Let's find my critical point. So if I'm looking, where is f of t the largest, what I'm looking for here is I'm looking for where f of t is equal to 0. Right? Because I'm saying, where are my critical points? That's where my derivative is equal to 0. And so what I'm looking for is, where are the places where my derivative is equal to 0? Okay, that's one way that we can kind of look at it. Now, if I'm looking at this over here, the problem though is I have this entering and exiting kind of thing, and that feels like a little bit weird, because then I'm gonna say how much is entering, how much is leaving, so on and so forth. So the other thing we can do is we can kind of look at this as a story. What this is telling me is, a certain amount of water is leaving, then water stops leaving and starts entering. So what's going to be happening is, I have a barrel, the water is going down, and at this point right over here, the water starts going up again. So again, you can either do this critical value wise, or you can use the graph to your benefit and kind of figure that out. So it says, the nearest gallon is water the greatest. So it's leaving, it stops leaving and starts rising. So this is going to be a low point. And then from here to here, water is rising. And then at this point at 3, it stops rising. It stops rising and starts leaving again. So this here is a possible max. And then from here to here, again, it's just leaving, leaving, leaving. And over here, it stops leaving. And then so this is my new low. And then the water starts rising again from here, here, here. And it just continually rises until the end. So here's my story. There are 4 sections. From 0 to 1.617, I have water is leaving. Then from 1.617 to 3, water is rising. Then from 3 to 5.075, water is leaving. And then from 5 on, it's rising. So there are 3 areas that we have to check for. Number 1 is here. This one, where my water rises, rises, and starts leaving. That's a relative max. So we have to check, is this the biggest? The next is this end point over here, which we know is going to be 7. Because it's continually rising till it hits 7. So again, this is another place where it starts rising. And the last place that we have to check is our end point over here, 0. Because before water started leaving, maybe only 100 gallons, or maybe 100 gallons left, but only 50 gallons came back. That means it never got back to its original glory. So because of that, we always have to check that. So generally what you're checking for are your critical points, where I'm going from positive to negative. Or if you look at it like a story here, you can kind of figure out, okay, where's my water entering? Where's my water exiting? Now, if you were looking at this in terms of critical values, what you're going to do is you're going to say the amount of water that's changing is going to be enter minus leave. And basically that's what you're doing here, except instead of doing that and doing the extra math, you're just interpreting the graph. So it's the exact same thing. It's still a sign chart, but instead of saying positive, negative, because you're adjusting the 2 graphs by like saying I have f of x minus g of x on this interval, f of x minus g of x on this interval, and I want to see when it goes from positive to negative, you're just looking at it and saying, okay, where's my water entering? Where's my water exiting? And then so you always do endpoints and where I have critical values and change. So these technically are all critical values. However, I only care about this critical value because I'm looking at where it's at its lowest or highest, and this is where it was rising and it starts leaving again. So again, interpreting the graphs and understanding what each of your functions are saying, absolutely vital. So what we're going to do here is the three places we have to check are are f of 0, f of 3, and f of 7. And again, the reason why it's capital F is lowercase f is saying what is my rate going to be. Capital F is saying how much water is currently there. Okay, so what we're going to do is this is going to be the integral from, this is just 5,000. And the reason this is 5,000 is it said earlier that it starts with 5,000 gallons. Next, f of 3, this is going to be integral from 0 to 3 of f of t dt. Let's make sure that that's what they're doing. Yeah, f of t dt. Minus integral from 0 to 3 g of t dt. So again, we're saying the total amount of water that came in minus the total amount of water that came out. However, this is just telling me the change of water. So if I want to figure out the actual amount, I have to add on the starting amount, which is 5,000. Now, g of t is actually really easy because it's 250. So basically, every hour it's adding 250. So after 3 hours, this is actually going to just be 750. So you can do either way, but again, finding those little ways to save time definitely helps. So then doing this, let me plug this into my calculator and see what we get.